Hello! Today I'm going to show you this integral. It's from MIT's Integration Bee 2020 and it's in the final round, question number 21. So the integral itself is we're going from 0 to 1 and we need to integrate a half plus x over 3 plus x squared over 8 plus x cubed over 40, etc, where each term is xn over n factorial n plus 2. And it says where the sum is infinite. So first step, we'll rewrite this sum as a summation basically. So we have the integral I is equal to the integral from 0 to 1 and the sum from n is equal to 0 to infinity of xn over n factorial n plus 2. And this has all been integrated with respect to x. Very nice. So the first thing to do is to remember that the integral of a sum is the sum of the integrals. So we can swap those two around effectively. So this is going to now be the sum as n from 0 up to infinity, and then the integral from 0 to 1 of xn over n factorial n plus 2, all with respect to dx, well, all with respect to x. Next step then is going to be noticing the fact that most of this isn't to do with x. So we've got n factorial and n plus 2. So we're going to basically take those out as constants and put them in the middle over here. So now we've got the sum from n is 0 to infinity of n factorial on the bottom, n plus 2, all underneath 1. And then the integral from 0 to 1 of xn dx. So we're now able to compute this integral over here. So we're going to do that on the next step. So the summation stays the same from n equals 0 up to infinity. This fraction stays the same. And this part then, well, when we integrate x to the n, we get x to the n plus 1 divided by n plus 1. So you raise the power and divide by the new power. And we need to evaluate this at the values of 0 and 1. So the next line, we're going to actually plug in these values, these 1 and 0, and see what we get out. So the sum, n equals 0 to infinity of n factorial multiplied by n plus 2, all under 1. And plugging in these values then, well, if we plug in 1, we've got 1 to the power of n plus 1. Well, 1 to the power of anything is just 1. So this is effectively going to be 1 over n plus 1. And when we plug in 0, well, 0 to the power of anything apart from 0 is going to be 0. But we can see here, so if 0 to the 0, we'd get 1. But 0 to, like the lowest value of n is 0, so this is always going to be 1 or greater. So we can just say that's going to be 0. So straight away, it's just going to be this term here, this 1 over n plus 1. And what we can notice now is we have n factorial multiplied by n plus 1 multiplied by n plus 2. Those things all combined are going to be 1 over n plus 2 factorial. So we'll put that in on the next line. That's n plus 2 factorial, all underneath 1, which is very nice. This is starting to look like we're getting somewhere. We're getting towards an answer. The next thing to do is a bit of a jump, and it's to think about, if we were to rewrite all these terms out, what have we got? Well, we've got 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, etc, etc. So we've effectively got the sum of all the factorials, but not the first two. So we're going to say that now. This is the sum from n equals 0 to infinity of 1 over n factorial, but then we're going to take off 1 over 1 factorial and 1 over 2 factorial. Making sure that that's the summation, taking off these bits afterwards. Let's think what that's equal to. So we can leave that alone for a second. N equals 0 infinity, 1 over n factorial. This part then, 1 over 1 factorial, and sorry, this should be 1 over 0 factorial. So we've got like the 0 and the 1. The first two terms basically getting missed off. So yeah, 1 over 1 factorial, that's 1. 1 over 0 factorial, that's also 1. So we're going to take off 2 here. And the next part then is we're going to inspect this summation. And we have to note the fact e to the x is equal to the sum from n equals 0 infinity of x to the n over n factorial. So if you don't know this fact, you're not going to be able to really solve this one. It's not something you're going to pluck out of thin air. But now that we know this, we can say, well, that tells us that if we just set x is equal to 1, so just e by itself is going to be equal to the sum from n equals 0 to infinity of 1 over n factorial. And that's exactly what we have here. So this entire term in here can be replaced with e, and that tells us then that our final answer, the integral, is equal to e minus 2. Very nice.